A Vernier Calipers was invented by Pierre Vernier. This device is used to measure length correct up to zero point 0.1 millimeter or 0.01 centimeter. A Vernier calipers consists of two scales. The first scale, called the main scale, is fixed, and the other scale, called Vernier scale, which is sliding over the main scale. The main scale is graduated with the value of 1 division on it is equal to 1 millimeter. The graduation on Vernier scale are such that the length of n divisions on Vernier is equal to n minus 1 division on the main scale. If you look at the Vernier scale, you can see that 10 divisions on Vernier is equal to 9 divisions on main scale. Thus, each division on Vernier scale is equal to 9 millimeter. Let us see how can we find out the least count of a Vernier calipers. The least count is equal to value of one main scale division divided by total number of divisions on Vernier. The value of one main scale division is equal to 1 and the total number of divisions on Vernier is equal to 10. So the least count is equal to 0.1 millimeter or 0.01 centimeter. Now let us find out the length of a rod using Vernier calipers. First, place the rod in between the lower jaw of main scale and Vernier scale as shown here. Take the division on main scale just behind the zero of the Vernier. We can see that third division after 4 centimeter is just behind the zero of Vernier. There is a small distance AB between the third division and zero of the Vernier can be seen. So the accurate length of the rod is 4.3 centimeter plus length AB. Also length AB is equal to Vernier reading into least count. Now take the Vernier scale division which coincide with the main scale division. Here you can see that fourth division on the Vernier coincide with the main scale division. Therefore, the accurate length of the rod is equal to main scale reading plus Vernier scale reading into least count, which is equal to 4.34 centimeter. Zero error. If the movable jaw of the Vernier, when touches with the fixed lower jaw of the main scale, the zero of the main scale and zero of Vernier scales coincide with each other, then we can say that the Vernier calipers is free from zero error. In this picture, you can see that the zero of the main scale and zero of the Vernier scale coincide each other. In that case, there is no zero error. If it do not coincide each other, then there happens a zero error. Depending on the type of error, there are two kinds of zero errors. One, positive zero error, and the next is negative zero error. On bringing the two jaws together as shown here, if the zero of the Vernier is at the right of the main scale, the zero error is said to be positive. The positive zero error is equal to the distance between the zero of Vernier from the zero of a main scale. To find this error, note the Vernier division coincide with the main scale division. The number of this Vernier division when multiplied by the least count of Vernier, we get the zero error. Here, the ninth division on Vernier coincide with the main scale division. So the zero error is equal to plus 9 into least count is equal to plus 9 into 0.01 equal to 0.09 centimeter. Negative zero error. In this error, the zero of the vernier is left to the zero of the main scale. In order to correct this error, subtract the vernier division coincide with the main scale division from the total divisions of vernier. On bringing the two jaws together, if zero mark of a vernier scale is to the left of the zero mark of the main scale, then the zero error is said to be negative. To find this error, note the division of the vernier scale which coincide with the division of main scale. Here, seventh division of vernier scale coincide with the main scale division. This vernier scale division is subtracted from the total number of divisions on vernier scale, that is 10, and the difference is then multiplied by the least count, that is 0.01 centimeter. Thus we get the zero error.